Yeah, today's class we'll see about the machine learning. Okay, what is machine learning and what are the types of machine learning, and we'll mostly see regression. Okay, today we'll see the regression type. Okay, firstly, let me explain about the machine learning. Okay, so machine learning is a subset of artificial intelligence that focuses on the development of algorithms that allows computers to learn from the data and make predictions. Okay, on the based on the data, right? We have seen already, right? So let me write the definition of machine learning here. Machine learning is a subset of AI that focuses on the development algorithms that allows computers to learn from the data and make predictions based on the data. So my question is, what is main input for ML algorithms? Tell me, guys, what is the main input for machine learning algorithms? Yeah, data, right? We have seen, right? So we have seen already, and for this question, the answer is the data, right? We have seen already how to define a machine learning problem, right? So let me open that thing. Yeah, we have seen this, right? Previously. So data is main input for machine learning algorithms, right? You know this thing. Yeah, we know this thing, right? For solving any problem, we have two approaches. One is traditional approach, another one is machine learning approach, right? So in traditional approach, we have to give the logic. Okay, we have to give the logic. We have to define the logic, right? So in machine learning approach, the algorithm learns it in the sense algorithm, right? Algorithm learns from the logic. Okay, I mean learns the logic from the data, right? In training phase. Okay, here we have seen an example, right? Here, this is the problem. To find a given number, whether it is a odd or even, right? That is a problem. For that, in traditional approach, what we have done here, uh, we have programmed a logic. Okay, programming. This is the logic for this is the logic for finding even or odd, right? Even or odd. This is the logic. In traditional approach, we have to code the logic. Okay. Whereas, in machine learning approach, the data is the main input, right? So assume we have this data. Assume we have this data. This is assumption. Okay. Assume we have this data, and we have to use machine learning algorithm. We have to use machine learning algorithm. And here, first question is, what type of algorithm to be used? Okay. And second question is, how it will automatically give output. Okay, so here I know you are having two questions in your minds, right? So what type of algorithm to be used here? Machine learning is a algorithm, right? What type of algorithm is I mean have to be used for this problem? So answer for this question is, it is based on output variable, right? Output variable. Based on the output variable, we have to select the machine learning algorithms. Okay, we have a lot of machine learning algorithms based on the output data type. That is, we have seen about the data type, right? We have seen about the data types. That is, there are mainly two types of data types are there. One is categorical data, another one is numerical data, right? So we have some n number of machine learning algorithms, out of which categorical data is having some machine learning algorithms, numerical data is having some machine learning algorithms. Okay, and how it will automatically give output. For this question, we'll discuss later. Okay, so here this is a what is the output here? This is the output. Is this categorical or numerical? This is the output, right? Y will take odd value, even value. Okay. Is this categorical or numerical? Respond all. Yeah, categorical, right? Absolutely. So this is a categorical variable. Y is a categorical variable. For that, we have to use some algorithms, some categorical machine learning algorithms. Okay, machine learning algorithms that is used for categorical data. Okay, we'll see what are the algorithms are there. Okay, and what are the algorithms for numerical data. Okay, we'll see all the kind of stuff. Okay, in that, so here tell me, this is output, right? In this case we have seen another example. This is output. What type this is? What data type? Tell me, guys. We have seen some other example. We have seen some other example, that is, I hope this is finding area of a rectangle, right? Area of a rectangle, out of which area is a output variable, and length and breadth are input variables, right? In that, area is corresponds to which data type? Numerical data. Yeah, exactly. Yeah, this is numerical data. For numerical data, we have set of algorithms, set of machine learning algorithms to be used. Okay, so we have seen all the kind of stuff, right? Okay, we have from in this class, that is today's class, we'll see about supervised machine learning algorithms. Okay, in detail. Okay, so before going to that, let me give another definition of machine learning. Let's say, for example, definition 2 for machine learning. That is, machine learning is similar to mathematical function, right? We know already machine learning is similar to a mathematical function. It it will take input data, predicts output, and provide a response, right? And provides a response. Let's say, for example, this is machine learning algorithm or mathematical function. Okay, that will take input. Okay, and it will provide some output. Generally, we will we will use X for input and Y for output, right? So we can say machine learning as this also. Okay, out of which in machine learning, types of machine learning, there are mainly three types. First one is supervised machine learning, and second one is unsupervised machine learning, so not machine learning, and third one is reinforcement learning. Okay, out of which we'll see mostly about supervised machine learning. Okay, so here we'll start with supervised machine learning. Okay, so what is supervised learning actually? So supervised learning, in this, the model in the sense machine learning model, okay, is trained on a label data set, right? Where the desired output is known. So what is here? Here, what is meant by label data? So in label data, the data set comes with both input and output. Okay, let's say for example, X is the input, Y is the output. Okay, this is example one. This is a label data. Example two, X1, X2, X3 are the inputs and Y is the output. This is the label data. And X1, X2, X3. This is not a label data because Y is not there, right? So what is X and what is Y here for our convenience? X will denote as input and Y will denote as output. Okay. So let's say for example Y1, Y2, Y3. Let's say these are the columns. Is this label data or not a label data? Tell me, guys. Is this label data or unlabeled data? Is this my question is this labeled or unlabeled? Tell me, guys. Is the given example is labeled data or unlabeled data? So yeah, let me ask some other question. this is example 4, right? So let's say example 5, x1. Only x1 is there. Is this label data? Same question here. Is this label data or unlabeled data? For example 5. For example 5 here I'm talking about this one. Is this label data or unlabeled data? Here what is there here? Only input is there, right? Is there any output? Is there any output? Yeah, unlabeled, exactly. Yeah, similarly for example 4. Is this label data or unlabeled data? Data set. Is this label data set or unlabeled data set? For example 4. Abhishek, is this label data set or unlabeled data set? Example 4. Tell me guys. Yeah, unlabeled data, exactly. Right. So I hope you guys have clarity on label data and label data, right? So in supervised machine learning algorithms, in supervised learning, again there are two classifications. Okay, again there are two things are there. We'll see about those things. Okay, in supervised machine learning algorithms, there are two things. One is regression, another one is classification. Okay, so here regression machine learning algorithms are used when output variable is numerical in nature. Okay, whereas in classification machine learning algorithms, okay, are used when output is categorical in nature. Okay, used when output is numerical in nature. Classification is used when output is categorical nature. Okay, before going to that, today's class will probably see about the regression. Okay, we'll see what are the things are there in regression, what is meant by regression. Okay, what are the algorithms are there in regression. Okay, so before going to that, let me give you some examples. Let's say for example, we have some tabular data with weight, okay, and age and height. Okay, we know that these two are inputs, this is output. Okay, what algorithm is to be used for predicting height? Okay, there are two types of algorithms, right? Machine learning algorithms. One is regression, machine learning algorithms, regression and classification, right? Out of which type of machine learning, supervised machine learning are to be used in this case? Let's say, for example, example 1. Okay, is this numerical or categorical? Firstly, tell me, height is numerical or categorical? Yeah, exactly, regression, right? So because why regression is to be used in this case, this is numerical in nature, right? This is numerical in nature, therefore regression algos are used. Okay, and we'll see some other example too. Let's say user information. Okay, and whether he click on add, this will take yes or no. Okay, this is the data. Let's say for example we have some user one information. He click add yes. Let's say user two information, he does not click add, up to so on. In this case, this is input, this is output. What I mean, same question here. Is regression or regression be used, or classification be used in this case? Classification, yeah, exactly, right? Why? Because output is categorical in nature. Categorical in nature, right? Okay, I hope you guys got clarity about this, right? So here we'll see about the regression. What is regression? Regression. What is regression? Anybody knows about regression? Yes or no? This is the first time you are hearing. Anybody? Yeah, Abhishek, yes. Anybody? Okay, let's see what is meant by regression. Okay, so regression is a statistical method used for predicting continuous outcome or continuous output. Okay, let me write here what is meant by regression. A regression is a statistical method used for predicting continuous outcome. Okay, based on one or more input features, right? So what is the purpose of regression? So what is the purpose of regression? I mean, what is the, you know, what is the use of regression actually? Tell me some examples in real world examples for regression. Tell me any examples that uses yeah, exactly, stock price prediction. Yeah, Abhishek. Any other examples? Any other real life examples where the regression can be used? Yeah, real estate price prediction. Yeah, house price predictions based on the size of house or location, number of rooms, number of bathrooms, number of bedrooms. All these are features, right? That can be used in real estate. Okay, so that is the purpose of regression, right? So here, the main purpose of regression is to identify the relation shifts between variables and understand patterns and make future predictions, right? Let's say, for example, uh, predicting a stock price and predicting house price based on features like size of house, location, number of rooms, etc. Right? This is the purpose of the regression, right? In regression, our goal is, let's say, for example, goal of regression. Here in machine learning, the regression goal is, let's say, we have, okay, let me write, given a training set having n observations. Okay, let's assume we are having n observations. Let's say that is xn, where n is from 1 to 1 comma 2 up to so on, right? And together with corresponding target values. Let's say target value is denoted by T of n, which n is running from 1 to up to so on n, right? The goal is to predict value of t for a new value of x, right? Our goal is to predict value of t for a new value of x. Okay, what does it mean? Let's say, for example, they are talking about two variables, right? Here, two variables are there. One is x, and another one is y, t, right? So here we have some n examples. Let's say, for example, 1, 2, up to n. Okay, here some x value is there. Okay, let's say, for example, we are having x1 corresponding t1, x2, t2, right? Up to so on. We are here, we are having xn value and tn value, right? So our goal is to predict what is the n plus 1 value, okay, future value. We have to predict this value. This is, let's say, for example, xn plus 1. What is the value of tn? This we don't know, right? Okay, understood, right? This is the goal of the regression, right? We have to predict the target variable for new x's. We have to predict, that means we have to predict the target for target t, new x, right? Understood, right? Understood? Are there any doubts? Clear? Yeah, clear, right? So we'll see what are the common regression algorithms are there. Okay, common regression algorithms. Okay, in that first one is simple linear regression. Okay, and second one is multiple linear regression. Multiple linear regression. Okay, and third one is polynomial regression. Okay, and fourth one is logistic regression, and up to so on. We have a lot of regression algorithms are there. Let's say, for example, fifth one is decision tree regression. Okay, sixth one is random forest regression. Regressor. A lot of regressions are there, out of which we'll discuss about first one and second one. Okay, and also fourth one. This is classification algorithm. Okay, this is classification algorithm. Why it is classification, we'll see. Okay, in that, firstly, we'll see about the simple linear regression. What is meant by simple linear regression? Okay, let's say, for example, in simple linear regression, we have to found out the relation between two variables. Okay, and one input variable is there and one output variable is there. One. Okay, one output variable is there. We have to find the relationship between these two variables. Let's say, for example, we have one variable. Let's say, for example, study. Okay, in terms of hours. Okay, and exam score or exam grade. Let's say exam score. Okay, let's say, for example, you have done 2 hours of study, you will get around 12 marks, and 4 hours of study will get around 16 marks, and 8 hours of study will get around 28 marks, and 16 hours of study you'll get around 62 marks. We don't know about 5 hours of study and how much exam score will get. Yeah, we have to find out this thing. To find out this thing, we have to analyze this entire data, and we have to find out the relationship, right? The relationship between the study and exam score. For time being, let's say study is represented as X and exam score is represented as Y. Okay, because this is output, right? Why this is output? Because we don't know this thing, right? That is why this is output. Okay, so in simple linear regression, this relationship is find out by using some equation. Okay, that is simple linear equation. Okay, y equals to mx plus c. So this is in this case this is exam score. X is study. Okay, sorry. X is study. These two are variables. M and C are variables. That is the relation we have to find out. What is M? What is C? Okay, these are called variables. Not variables. These are called parameters. Okay, parameters we have to find out. Okay, that is our goal. To relate y and x, we have to form a equation. Okay, we have to form a equation. In simple linear regression, we have to form this equation. Okay, based on the y values and based on x values, we have to find these two, m and c. Okay, based on m and c, we have to find out new value of y, right? value of y based on the given value of x. To solve, therefore, there are two methods actually to solve for m and c. There are two methods. Okay, first one is least square method, and second one is gradient descent method. Okay, there are two methods are there to solve for m and y. Okay, to find out m and y. Okay, in least square method, there is a big mathematical derivations are there. By doing those derivations, we have some m value is something and c value is something. Okay, and we have to use these m and c. Okay, you know this, you don't know this value, you know this c value, you know this x value, you know this c value, right? For any given value of x, you can find y, right? Got it, right? Okay, I know this is some mathematically heavy. Okay, these things are mathematically heavy. Okay, we'll not go into the math. We'll see about mission. I mean, that is programming way only. Okay, I'll try to reduce the things into the programming way. Anyways, understood, right? Till now, understood. Yes or no? Yes, right. Okay, understood, right? How to relate the input and output in simple linear regression. Are you feeling any math heavy, or are you not understanding? No, right? Yeah. Okay. Let me continue. So by using grade least square method, some big derivation is there for finding m and c values. Let's say okay, I'm giving m and c values directly. Okay, here m equals to n into summation of xi into yi. Okay, minus summation of xi into summation of yi divided by n into summation of xi square minus summation of xi whole square. Okay, this is m value, and let me give you c value. C value equals to summation of yi minus m into summation of xi divided by n. Okay, here n is corresponds to number of examples. N is nothing but of examples. Okay, let us solve a problem, simple problem. Okay, wait for a while, guys. I'm getting some call. Yeah, here let us solve an example. Uh, Consider a data set of points x, y. Okay, x is taking 1, 2, 3, 4, 5. Corresponds to y values are 2, 3, 5, 7, 8. Okay, and the question is find the best fit line y equals to mx plus c using least square method. Okay, so for this we have to use these two things, right? We have to use uh, for this line y equals mx plus c, we have to use this relation, this m and this c. Okay, we'll solve this. So for this, y x y and x into y and x square. We require these things, right? For this, we have to we require x into y and the summation x into y is there. Yeah. The given things are 1, 2, 3, 4, 5, right? And here y is 2, 3, 5, 7, 8. Okay, what is x into y? 1 into 2 is 2, right? 2 into 3, 6, 3 into 5, 15, 28, here, 40, right? And we will see the summation also. What is this? This is summation of xi. What is summation of xi? All sum is 15. Right? This is summation of yi. Okay, each and every point summation, right? And what is this? This is 25. Okay, this is summation of x into y. Xi into y, right? What is this? This is around 91. So we'll say x square. X square is 1, 4, 9, 16, and 25. What is the summation of xi square? Xi square, what is summation? 25 plus 16, 16 plus 9 plus 55, right? Okay. Here, what is m? M equals to n into summation of xi into yi, right? Summation of xi into summation of yi minus n into summation of xi into yi divided by n into summation of xi square minus summation of xi whole square, right? By substituting the values here, n is 5. Number of examples is 5, right? N equals to 5 into 91 minus 15 into 25. Here n is 15. Summation of x and y is 91, right? Divided by n is 5. Sorry, 5 into summation of x square is 55 minus 15 whole square, right? By simplifying that, you will get around 1.6. Okay, similarly for C, if you substitute all the values in C, that is in this value, you will get around 0.6, 0.2. Okay, by simplifying that, y equals to 1.6 x plus 2, 0. This is the best fit line for this data. Okay, let's say for example, I'm having sixth example okay, let's say for example, mu example equals to mu x equals to 7. What is the corresponding y? This is our goal, right? In regression, this is our goal. Simply, we have to use this equation. So y equals to 1.6 into 7 plus 0.2. it will use to give some value that corresponds to y. Okay, that corresponds to y. Understood? Yes or no? Clear, right? How to calculate m and y values. Anyways, these are not required for you, but I'm telling for the completeness sake. Okay. Okay, we'll see how these points looks like. Okay. Uh, Regression. Yeah, linear regression calculator. So here we'll see what are the x values. What are the x values? I hope 1, 2, 3, 4, 5. Right? What is corresponding y values? Y values are 2, 3, 5. So 2, 3, 5, 7, 8. Right. So we'll see the values. So here the line is fitted, right? The model is fitted well, right? You can see here the slope. The slope is nothing but m value. M value is 1.6, right? And y-intercept, that is c, constant is 0.2, right? The line is fitted well. Let's say for example, I have given another point of x. Let's say for example, I have given the sixth value. Here I have given some sixth value. X equals to 6. Corresponding y is this one, right? So for example here, corresponding y is around 8 point something, right? That's why, that's how you calculate the x and y values. Y values for new x. Understood? Yes or no? Yeah, understood, right? That is all about regression by using least square method. Okay. And one more method is there, regression by using gradient descent method. This method, uses, a lot of machine learning algorithms uses gradient descent method. Okay, gradient descent method to calculate parameters. Okay, that is m and c in the case of simple linear regression. Anyways, simple linear regression will take only two parameters. Okay, one is m value, that is slope value. Another one is intercept. Okay, some other models are there. A lot of complex models are there. Let's say, for example, y equals to complex equation. Let's say, for example, some big equation is there. A lot of big equation. Okay, in that a lot of parameters are there. A lot of parameters are there. Those parameters are calculated by using some other math function. Okay, similar to simple linear regression. The process is similar, but the mathematical steps may vary. Okay. In simple linear regression, only two parameters are there, right? So common regression algorithms are simple linear regression, we have seen, right? And multiple linear regression. Similar thing, this will take only one x and one y, right? In multiple linear regression, we'll have one x1, one x2, x3 up to so on. One y is there, right? So here, what is the use of simple linear regression? Let's say, for example, we have weight. Okay, let me ask a question. Question is, what is the real usage of simple linear regression? Real. Tell me, guys. Only by using only two variables, one x and one y. What is the use of simple linear regression in real life? Tell me. Anyone? What is the real life usage of simple linear regression? Any guesses? Predicting height using weight. Yeah, exactly. That is one example. Any other guesses? Yeah, some other thing is predicting sales and demand. Okay, let's say for example, demand is a input variable and sale is an output variable, right? That is also a real life example for a simple linear regression. And a lot of examples are there, right? Let's say for example, agriculture yield. I mean, how much agriculture production will be produced based on the crop area, okay, area of the crop. That is also some other example for simple linear regression, right? Any questions on simple linear regression? Any questions are there? Yes or no? All right. Okay. Wait for a while. I'm creating some quiz. Okay. After that quiz, you can left the class. Okay. That's all for today. Wait for 5 more minutes. I'm creating a quiz. Okay.